Right. So we're looking at resultant forces in um, in 2 dimensions. Now, in this first one, it's actually quite easy because the up and down force cancel out. So we've got 300 cancel out with 300, and then we did 900 take away 400, and so we've got a force to the right of 500 newtons. That's not too bad. Now, the problem with the one below is they don't cancel out. So we can imagine the force is going to be somewhere like this direction. If you were pulling up and to the right, it would deflect at an angle, some angle, we'll just call it theta. But there is a way of working out what that angle is and what the size of the force is. So to do that, what I'm going to do is show you another way of imagining how this one would be done. What we're going to do is we're going to take some arrows, and we're going to say that's 900. That arrow represents 900. So we could maybe imagine it was an arrow of 9 centimeters long, and then we're going to just stick all the other arrows, the tail of each arrow on the head of the previous arrow. So we've got a one would be 3 centimeters going up, and then we've got another arrow which would be 4 centimeters going to the left, and then we've got another 3 centimeters going down. And to work out the resultant force, it's just going to be the beginning of the whole thing, the start, to the end of the whole thing. And because we know that that first arrow was originally representing 900 newtons, and we know that this one up here is 400 newtons, then you can see the difference is 500 newtons. So we get the same answer. And of course, these were 300 newtons and 300 newtons. So they, as you can see, they would cancel out if you drew them like that. So now we're going to think of adding forces, and in fact, all vectors in that way, the head to tail method. So we can do the same thing with this one here. You can use that approach for this one here. So if you had 5 newtons, this one representing 5 newtons, let's just write 5 newtons on the arrow. And then one over here representing 12 newtons, and we can write 12 newtons on that. Now we could actually make this to scale, so 5 centimeters and 12 centimeters if we like, but we don't have to if we know Pythagoras, because that's a right angle, and this is the start, and this is the end, just like before. So now the from start to the end is going to be another line, which we're going to colour in green, and that is like the hypotenuse of a right angle triangle. So we know that a squared plus b squared is equal to c squared from Pythagoras. A squared and b squared are just either it doesn't matter which way around you do them. And c squared is the hypotenuse. So this one here, we're going to call that c, is going to equal to, or c squared is going to be equal to 5 squared plus 12 squared, which is equal to 25 plus 144. And so when we add those together, in my head, so that's 169. So C is going to be equal to the square root of 169, which is, it's actually a whole number, which presumably shows us that we've done the answer right, because it's actually 13. So the answer's 13 newtons. So that's how you do those kinds of questions.